Bill Nye the Science Guy. Bill Nye the Science Guy. Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter.
Bill Nye the Science Guy.
T minus 7 seconds.
Bill Nye the Science Guy.
Hey guys, Ryan the Physics Fan here, talking about everything physics. There are physics all around us. There's physics in our home, physics outside, but a lot of this physics stuff is physics we use in everyday objects. Take a ball for instance. You got so many physics into this little thing right here, but people don't realize it. People use this for hunting, fishing, but they think it's just shooting the bow and, you know. But there are a lot of concepts that go into how this bow works. I'm going to talk about those 3 concepts today. The 3 concepts are potential energy, kinetic energy, and the law of conservation of energy. Alright, now let's identify the 2, potential and kinetic energy. First, potential energy. Potential energy is pretty much the energy stored into the object, or the energy that is held at readiness. So for instance, if I was to hold the bow like this, the bow is now ready to shoot, and it has full potential, and full potential to shoot. Yep. Alright, now kinetic energy is pretty much the energy in motion. That's pretty easy to remember. But if you want to remember potential energy, think potential and position. Alright? Now the law of conservation of energy is the law that states that energy cannot be destroyed or created, but can be transferred from one form to another. Alright, let's demonstrate what I mean by these concepts. Alright, so right now the bow is at 0 joules of potential energy right now. But now this bow has about 50 pounds of draw weight to it, so it'll take about 50 joules of work to make it pull back. And you know, we can't do work without having energy. So now the bow is at 50 joules of potential energy. Now watch what happens when I release the bow. See, the bow is at potential energy, and now it's converted into kinetic energy. But what happened to the arrow? Well, as the kinetic energy from the bow was transferred from the bow to the arrow, making the arrow fly. For those of you who haven't seen it, let me show you what I mean. Now I have the bow drawn like this, and the arrow has full potential, right? Now as the string comes out like this, and it stops, it has to convert its kinetic energy from the bow itself into the arrow to make it fly. Otherwise, if you don't convert kinetic energy into another object, like an arrow, it's not going to do very well. And this arrow will not fly. And what I mean by the string stop is it's got this little string stopper right here. The string has to stop when at either way possible. So otherwise, if the string doesn't stop for it to be converted from the bow to the arrow, then the string will break. And let's shoot this one more time so you understand. Alright, so the bow is at 0 joules of potential energy, right? Now, as I pull the bow back, now it's at 50 joules of potential energy. And now, as I release it, the bow had 50 joules of kinetic energy, and now it was converted from the bow to the arrow. Now the arrow and the bow are at 0 joules of potential energy. Okay, that's about all the physics I can do, so thanks for watching. Remember, physics can be fun and it can be educational. Thanks for watching. Here's something you can do at home. it's kind of, in case you're not comfortable with the bow, you can get some rubber bands. Doesn't matter what size you get, you can do it with all sizes of rubber bands, but it's kind of this is kind of a safer demonstration, so you know you guys don't get hurt and you know have to go to the hospital or what not. But what you can do is you can pull the rubber bands back as far as you can and see how far you can get with them. See, that one went pretty far, but it's kind of hard with these smaller ones, but it's pretty much the same idea. You can get pretty far with these, but do them at home. Don't be trying to go to school and doing it, you know, because I don't want you to get in trouble and have you come talk to your teacher saying that Ryan told you it was fun. But you know, but it's kind of a fun demonstration, you know. You can do it at home and kind of bug your sister with it. No, don't bug your sister, but you can try, but you'll probably get in trouble. But yeah, that's all I have, but thanks for watching.
Consider the following.